Alright, so this is going to be another video about simplifying imaginary numbers, and I have 5 examples here. I'm just going to kind of work through them, and hopefully it makes this whole concept make a little bit more sense. Alright, so for this first one, what I'm going to do is actually try to simplify everything, factor everything out first, just because it's going to lead to less hassle later on. So I'm going to pull out the perfect square that's in that 18, which is 9. So square root of 18 becomes the square root of 9 times the square root of 2, because the square root of 2 times the square root of 9 is equal to the square root of 18. So kind of color code this here. And then we're going to multiply it by the square root of c here. Then I'm going to multiply this by, I'm going to pull out that square root of -1 right away. Then you're going to have the square root of 2 times the square root of c to the third. I'll just write that really quick like that. Okay. From here, I'm going to simplify as many things as I can. So this becomes a 3. This and this are going to cancel just to become a 2. So it'll be 3 times 2 here. So we're going to have a 6. This right here becomes an I. So I'm going to say 6i for this one. And then we have the square root of c times the square root of c to the third. So this is going to be times. All right, so what I'm going to do for this other part here is I'm going to write the square root of c here, and then I'm going to multiply it by, I'm going to take out the perfect square that's in this, which in this case it's going to be c squared, times the square root of c. So essentially what I did here is this whole part right here is equal to this part. Okay, the two things that I highlighted in green are equal to each other. All right, now from here, I'm going to combine the square root of c times the square root of c, which is just c. So it's going to be 6i times c, square root of c times square root of c. It is important to understand, though, that it has to be positive. So c can't just be anything. So I'm actually going to put an absolute value bars on that one. And then I'm going to do the exact same thing here as well. Okay, c squared, whatever c is, if it's squared, it becomes positive, and then the square root of it is also going to be positive. So again, you have c times c here, both absolute values. Now, what's great about this is the absolute value of c times the absolute value of c is just going to be c squared, and c squared is always positive. So what you can do is rewrite this whole thing to be 6c squared times I. And that would be the final answer for this one. All right, let's go to the next one. All right, this time we have some rational expressions here, some fractions underneath the square root. So this makes it a little bit more complicated, but it's nothing we can't handle. Same rules apply here. So the first thing I'm going to do is actually pull out that square root of -1 here. So I'm going to do the square root of -1 times the square root of r over 5. I'll put the square root there. And then we're going to multiply this by, I'm going to take out the square root of -1 over here. So it's going to be times 20 over r, but the square root of this, so we end up with something like that. Okay. Now, the square root of -1 times the square root of -1 is just I times I, so I'm going to write I squared, which is equal to -1. And then what I'm going to do here is combine the square root of r over 5 with the square root of 20 over r, so you're going to end up having 20r over 5r, and it's the square root of all that. Okay, so basically I just multiplied across. R times 20 is 20r, 5 times r is 5r. Now this simplifies for us here, so 20 over 5 is 4 over 1. The r's cancel, so you end up having the square root of 4, which is just 2, times I squared, which is -1. So your final answer ends up being -2. All right, so this one is similar to the problems we've already done, only this time there's 3 terms to it, so but the same rules still apply. So we're going to do the square root of -1 here, and in fact, I'm just going to write an I right away, and that's times the square root of 2 times the square root of t to the 5th, plus, again, I'm going to pull out an I here, and then we have the square root of 8 times the square root of t to the 5th, minus, again, I'm going to pull out an I here, and it's the square root of 18 times the square root of t to the 5th. Okay. So if you notice, every single one of these terms has an I times the square root of t to the 5th as a common factor, so they all have that in there. So that means we're going to be able to combine those together later. But for now, let's simplify this as much as humanly possible. So the t to the 5th, what you can do for that one is you can pull out a perfect square of t to the 4th. So you have the square root of t to the 4th times the square root of t plus I times the square root of 8. Now the square root of 8 actually breaks down to the square root of 4 times the square root of 2. So there's a perfect square in there of 4. And again, we're going to do the square root of t to the 4th times the square root of t minus I, okay, and we're going to pull out a square root of 9 because it's a perfect square in that 18, the square root of 18. And then we're also going to pull out the 2 here because 9 times 2 is that 18 times, again, we're going to do the square root of t to the 4th times the square root of t. Okay, so lots to simplify here. Well, t to the 4th, if you take the square root of it, that's just going to be t squared. So this is going to be t squared times the square root of t, and then this is just going to be root 2 times I here. Okay, I'm going to do the same thing here. This is going to be 2, so it's going to be 2 root 2 I. I'll put the I at the end. So it's going to be 2 root 2 times the square root. So it's going to be 2 root 2 times t squared times the square root of t, again, times I. Minus, this is going to be 3 here, so it's going to be 3 root 2 times t squared root t times I. And then from here, because we have like terms here, so because we have like terms here, we can combine all of these. So it's going to be root 2 plus 2 root 2, which is 3 root 2, minus 3 root 2. So you end up actually with a 0 on this, which is kind of a weird answer, but that is the answer. All right, now the next one is a little bit different because we end up having an I on the top and on the bottom. And when you're simplifying imaginary numbers, you cannot have an I on the bottom. So we notice this I right here, that is against the rules. So in order to get rid of that, what we need to do is multiply by the conjugate of that bottom part. Okay, and if you remember from previous videos, the conjugate just means it's the twin, only the operation in the middle is the inverse of it. So if it's plus, then it has to become minus. If it's minus, it becomes plus. Those are what conjugates are. I like to kind of think of them as like good twin, evil twin. Like this 5 plus I is like the good twin. It's positive, it's got a plus. And this 5 minus I is the evil twin because, you know, it's got a negative in there. But everything else is the same. That's why they're like call them twins. But I always think of conjugates as good twin, evil twin. All right, so the very top part, we're gonna have, it's this 6 minus I times 5 minus I. So what we're gonna do is use the area model to actually figure out what that product is. So 5 minus I. Okay, and what we're gonna do is just fill in the area like we always do. So negative 5I, negative 6I, and it's going to be positive I squared, which is just going to be negative 1. Now that bottom part is the conjugates multiplied together. So it's 5 plus I times 5 minus I. So again, we're going to do the area model for this. So you end up with 25, and then you have 5I. You have negative 5I here, which is going to cancel those two, and then you have negative I squared here. Okay, so this is going to cancel with this because negative 5I and positive 5I are going to cancel out. So at the top, based on what we have here, I'm going to try to color code this too. So at the top, you should have 30 minus 11I, because I combined this and this, plus I squared, which is negative 1. And then we're going to divide all of this by 25 minus I squared, which is going to be plus 1. So it's going to be minus negative 1 is just a plus 1. And then you end up with 29 minus 11I all over 26. Okay, again, it is important to understand that you can check these on your calculator as well. You can just put the original problem, this whole thing right here, in the calculator, and you should be able to check your work on that using the calculator. All right, now the last one is similar to the one we just did, only this time it has some radicals in it as well to make it a little bit more tough. All right, so the first thing I'm gonna do is, again, you cannot have an I on the bottom for whatever reason. So we're gonna use conjugates. So in this case, it's a plus, so you have to turn it to a minus to basically get rid of that I on the bottom. Now, if you notice in the previous example, when we multiplied by the conjugates on the bottom, you end up with a real number. There's no I on the bottom anymore. So that's essentially what we're gonna be doing for this one as well. When you multiply by those conjugates, it gets rid of any imaginary part for that expression. All right, so that top part, I'm gonna do the area model really quick just to, so I'm gonna do the area model really quick to find that product. All right, then I'm also going to do the area model for that bottom when you're multiplying across from the 2 plus 4i times 2 minus 4i. All right, so we have the product of the numerator and the product of the denominator, so I'm just going to rewrite that really quick. All right, so you end up with something like this, and all right, so the next thing I'm gonna do is combine these down here to get 20. And if you notice, every factor at the top has a multiple of 2 in it. So like this is 2 times 3, there's a 2 here, this is 2 times 6, and this is 2 times 2. So what I'm gonna do, and you have to do this to completely simplify everything, is divide the top and the bottom by 2. So that 2 should be gone for each of these. So that 6 divided by 2 is gonna be 3 minus root 3 times I minus 6i minus 2 root 3. And then we're going to divide this all by that by 2 as well, so that's going to be 10. So I'm going to rewrite this so it's a little bit neater here. Your final answer should be 3 minus root 3i minus 6i minus 2 root 3 all over 10. So that's a video on simplifying imaginary numbers. Hopefully those 5 examples help you understand this concept a little bit more. If you have any questions about anything in this video, let me know.